Quick Trig, episode 5. In episode 5, we'll be talking about the sine of a sum and the cosine of a sum. Here we go. Now, I'm going to draw a picture that gets pretty complicated after a while, but it really all boils down to two triangles that I use over and over again. And those two triangles look like this. Suppose we have a right triangle with an angle theta and a hypotenuse 1. We've seen in episode 1 that the adjacent side will have length cosine theta and that the opposite side will have length sine theta. Then, if I take this triangle and scale it up to be a bigger triangle, I want the same angle here. So these two triangles are similar triangles. Rather than hypotenuse 1, now we're going to have hypotenuse r. Well, what happens is you just multiply all the side lengths by r. So this would be r sine theta, and this would be r cosine theta. Notice, it's still the case that the opposite divided by the hypotenuse, r sine theta divided by r, is still equal to sine theta, as it should be. Likewise, if you take the adjacent side and divide it by the hypotenuse, r cosine theta divided by r, you get cosine theta, as it should be. I'm just going to use these triangles over and over again here and build up a pretty big picture. But here we go. I'm going to start like this. I'm going to put an angle here, call it angle B. And then on top of that, I'm going to put another angle, angle A. Now, these two angles might be different sizes, and they might be the same size. I think I've got it pretty close to different, well, I think they're obviously different sizes there. So first thing I'm going to do is drop a perpendicular down here. And I'm going to call this side over here length 1. Okay. And so the first thing I notice here is that I've got a right triangle with a hypotenuse of length 1. That's this picture right here. So I know that the adjacent side, right here, this length is going to be the cosine of whatever this angle is. Well, that angle happens to be a plus b. Likewise, I know that the opposite side, and now what I'm going to do is I'm going to say this whole thing right here, this length, is going to be the sine of that angle. So this is the sine of a plus b. Okay. Now, I've used this picture right here once. Now I'm going to, from this corner, drop another perpendicular, although this time it's going to be down to this side. So here I have, again, another right triangle. I have, just think of angle A here. I've got a hypotenuse of 1, this side over here, a right angle, and then this side down here. Okay. So, using that picture again, I can say that this side right here, which I'll do in red, is the cosine of angle A, and this side here is, I'm going to turn the paper for a minute, hope I don't make you too dizzy, the sine of angle A. There we go. So I've now used that triangle twice. Next, from this point, I'm going to drop a perpendicular down here. So this and that are parallel to each other. Now I'm looking at a triangle down the bottom here with angle B. So the hypotenuse there is no longer length 1, it's cosine A. So it's playing the role of this triangle with the hypotenuse of R. Well, R is going to be cosine A here. Okay, so this tells me that the opposite side from angle B should be R times the sine of theta. Well, theta in this case is B. So R is the cosine A, and then I got to multiply it by the sine of that angle, sine beta. Okay. Now I have the adjacent side, so it's this whole side, all the way from here out to there. So that whole thing, all the way out to there, is the adjacent side, R times the cosine of the angle. Well, the R is cosine theta. No, it isn't. It's cosine A. And now I need cosine of this angle B. Okay, so I've got a side length here, hypotenuse times sine B, and I've got a side down here on the bottom, which is the hypotenuse times the cosine of B. Okay, so now I've used this triangle twice, that triangle once. I have one more triangle to draw. I'm going to take this and extend this thing straight up until I get to the same elevation as this, so that that's a right angle. So this top line is parallel to this bottom line down here. Okay. Now, this may be the trickiest part of the whole proof, is that this angle right here, is it obvious that that angle is the same as angle B? Well, I see it this way. This angle right here, 90 degrees, and B are the three angles of a right triangle. So if you're doing it in degrees, then you add up, those three angles add up to 180 degrees. Now I look up here. This angle, 90, and whatever that angle is, also add up to 180 degrees. Well, this angle and 90 were the same as this angle and 90. So this one and that one must be the same. This is angle B right up here. Okay, so now I'm looking at this little triangle up on the top. I have angle B, and the hypotenuse has length sine A. So I'm looking at this kind of triangle right here with r equal to sine A. So the opposite side should be the hypotenuse times the sine of the angle, and the adjacent side should be the hypotenuse times the cosine of that angle. Now I have a couple of identities, because this side length from here down to there we originally said was sine of A plus B. But now I have here two edges that add up to the same length as the original long one did. Sine A cos B plus cos A sine B. And then down at the bottom, this is fun as well. We've got the cosine of A plus B equals this whole length minus this little length. Well, that little length is the same as it was up there, sine A sine B. So the cosine of A plus B must be the whole big long length, which is this, cosine A cosine B, minus that length right there, sine A sine B. And so I have two identities out of this one. There's the sine of a sum, and here's the cosine of a sum. We will use these identities to prove a whole bunch of other ones. Right? So this picture right here, we take a little bit of extra time on to make sure we've got it down. This triangle twice, that triangle twice, gives us two nice identities.